Welcome to today's Explainer, everyone. I am absolutely thrilled to have you here. If you're an 8th grade focused learner tuning in, well, get ready because we're about to embark on a super exciting hands-on journey into the geometry of our physical world. Today, we're looking at the really intricate relationship between faith and form, exploring the math of three-dimensional volume. We're going to master the shapes that make up the world around us, and honestly, I promise you, by the end of this, you'll never look at a soda can or a basketball the exact same way again. Okay, let's dive right into this. Psalm 19 verse 1 tells us, "The heavens declare the glory of God, the skies proclaim the work of his hands." You see, the physical world around us isn't flat, and it certainly isn't accidental. God designed creation to be deep, wide, and full of incredible purpose. When we study the physical dimensions of things, like when we calculate how much space is actually inside them, we're literally uncovering the careful, deliberate mechanics of that design. So learning this math isn't just about, passing a test. It's about understanding the three-dimensional blueprint of the universe itself.
Here's the roadmap for our journey today. First, God's three-dimensional world. Second, essential 3D volume formulas. Third, real-world volume examples. Fourth, test your math skills. And finally, education with biblical morality.
Let's kick things off with Section 1, God's three-dimensional world, understanding the space around us. Before we calculate anything, we really need to nail down the specific math concept we use when measuring physical creation, and that concept is volume. Simply put, volume is the amount of space inside 3D shapes like cylinders, cones, and spheres. Now, you might be wondering, why does this matter so much in real life? Well, think about it. We use volume every single day. We use it to fill objects, ship cargo containers, or store vital resources. Whether it's a small soda can in your fridge or a massive water tank supplying your entire neighborhood, knowing exactly how much space is inside helps us plan wisely. Out in the real world, like in science, engineering, and construction, measuring volume accurately saves time, it saves money, and it saves materials. It literally teaches us to think in 3 dimensions.
Moving right along to Section 2, Essential 3D Volume Formulas, the Mechanics of Measurement.
So to figure out volume, we've got to apply the correct mathematical rules for each specific shape. Before we jump into the formulas, just keep 2 vital things in mind. First, your final answers will always be in cubic units. Second, unless the problem specifically tells you otherwise, we're going to simplify our calculations by using 3.14 for pi. Okay, here are the 3 essential formulas you absolutely need to master. For a cylinder, the volume equals pi times the radius squared times the height, or V equals pi r squared h. For a cone, the volume is 1/3 pi times the radius squared times the height, or V equals 1/3 pi r squared h. And for a sphere, the volume is 4/3 pi times the radius cubed, or V equals 4/3 pi r cubed. Now, what's really interesting here is how the radius, that's the r, and the height, the h, act as the fundamental building blocks across these different shapes. It's like a giant puzzle. You just identify your shape, grab your radius and height, and plug them right in. Now, when we compare the cylinder formula and the cone formula side by side, do you notice anything? They're almost identical. The only difference is that the cone formula has a fraction of 1/3 at the very front. Geometrically, this means if you have a cylinder and a cone with the exact same radius and the exact same height, that cone is going to hold exactly 1/3 the volume of the cylinder. It's this beautifully simple mathematical relationship that really helps you visualize how 3D shapes relate to one another. Keep that little 1/3 difference tucked away in your mind, by the way, because it's a massive hint for your upcoming homework.
Let's move to Section 3 and see how this all builds together. Real-world volume examples. Applying the math.
It's time to take these formulas and apply them to everyday objects you actually see in your life. Let's tackle our first example. Imagine a large cylindrical water tank out on a farm. It has a radius of 4 feet and a height of 10 feet. Because it's a cylinder, we'll use the formula V equals pi r squared h. Step by step, let's substitute our numbers. Volume equals 3.14 times 4 squared times 10. Remember, we always handle our exponents first. So 4 squared is 16. That means we multiply 3.14 times 16 and then multiply that result by our height, which is 10. Just track that math in your head for a second. And we arrive at 502.4 cubic feet. That little 3 on the unit, that is absolutely crucial. Because we're measuring 3-dimensional space, deep, wide, and tall, our unit must always be cubed. So that water tank holds exactly 502.4 cubic feet of water. For example 2, we're taking it to the streets. Think about a standard traffic cone. It's got a radius of 3 inches and a height of 12 inches. We pull out our cone formula, V equals 1/3 pi r squared h. Let's plug in those numbers.
volume equals 1/3 times 3.14 times 3 squared times 12. Again, square the radius first. 3 squared is 9, so now we're looking at 1/3 times 3.14 times 9 times 12.
When we multiply all of that together, the resulting volume of our traffic cone is 113.04 cubic inches. See how neatly that formula just unlocks the hidden space inside the shape?
For our final example, let's look at a basketball. A basketball is a perfect sphere. Let's say its radius is 5 inches. Our sphere formula is a little bit different, remember? V equals 4/3 pi r cubed. Let's carefully substitute. Volume equals 4/3 times 3.14 times 5 cubed. Now 5 cubed just means 5 times 5 times 5, which gives us 125. So we calculate 4/3 times 3.14 times 125. The result is approximately 523.33 cubic inches, and this brilliantly illustrates just how much invisible space is hidden inside a simple, everyday object. There's literally over 500 cubic inches of air trapped inside that basketball, which is exactly what gives it the bounce you need on the court.
Section 4. Test your math skills. Now it's your turn to calculate.
You've seen how this works, so please don't be intimidated. You have the formulas, and you know the steps. Here are your 5 homework assignments. Number 1. Find the volume of a cylinder, where the radius is 3 inches and the height is 7 inches. Number 2. Find the volume of a cone, where the radius is 5 centimeters and the height is 9 centimeters. Number 3. Find the volume of a sphere, where the radius is 6 feet. Number 4. If a cylinder and a cone share the exact same volume, how are the height and radius related? Remember when we compared those formulas earlier? And number 5. Create your very own real-world volume problem involving a cone, and then solve it. I highly suggest you pause the explanator right here, grab a notebook, write these down, and work through them step by step. You've got this!
And finally, Section 5, Education with Biblical Morality, the Hero Smart Academy Philosophy. For this final part, I want to take off my upbeat math teacher hat for a moment and speak to you just as a grounded mentor. This lesson is part of the Hero Smart Academy Godly Learner series, and their core philosophy is simple, but it is profoundly important. Education must be intertwined with biblical morality. Why? Because while mastering 3D geometry and formulas is incredibly vital for your practical life, education without morality is ultimately going to hurt you. Think about it. You can have all the technical skills in the world. You can know exactly how to calculate the volume of any shape imaginable. But if you lack the moral compass to use your knowledge for good, well, that education falls tragically short.
The foundation of this character is beautifully laid out in Scripture. Romans chapter 8, verses 6 through 7 promises genuine peace of mind to everyone who keeps their mind spiritual. When you frame your academic learning within a moral, spiritual context, you aren't just gaining raw data anymore, you're gaining actual wisdom. And this promised peace of mind? That is the true experience of people who engage with this curriculum. It brings a real harmony between what you know and how you choose to live.
So I want to leave you with this final, provocative thought. What is the point of being smart and supposedly educated if you just continue to make bad choices that hurt yourself and others? True education is not just about measuring the physical world around you, it's about properly measuring the character within you. I challenge you this week to pair your hard-earned mathematical knowledge with strong, unwavering moral character. Thank you so much for joining me in this explainer today. Keep calculating, keep growing, and I will see you next time.